All right. All right, let's look at the inverse of a matrix. Inverse of a matrix. Of course, we have a 2 by 2 matrix and a 3 by 3 matrix, and this follows different approach. So for a 3 by 3 matrix, the inverse, let's give it a raised to power minus 1. The inverse of a matrix A, written as a raised to power minus 1, is equal to 1 over the determinant of A, that's A, which is written as this, times the adjoint of matrix A. Alright, so what is the adjoint of a matrix? The adjoint of a matrix is simply the transpose of the cofactor of the matrix A. So if you're asked to find the adjoint of A, and we've already done cofactor, please. So if you're asked to find the adjoint of A, it's the same thing as saying the transpose of the cofactor of A. Alright, so this is it. In getting the inverse of a matrix A, you need what? Your determinant first. You calculate what? Your determinant. The first step you take is what? Getting the determinant of A. The next step you take will be what? The cofactor of A. That should be the next step, please. After getting the cofactor of A, you then get what? The transpose of that cofactor of A, right? After getting the transpose of the cofactor A, you've gotten what? Your adjoint. It's the same thing as the adjoint, obviously. So this is it. Your inverse of A then becomes what? 1 over the determinant of the matrix A multiplied by the adjoint of A, and you simplify. Then you're good to go. Alright. This is for what? A 3 by 3 matrix. Alright. If you're given a 2 by 2 matrix, let's say A, B, C, D. This is a 2 by 2 matrix, right? So in getting the inverse of this, you apply the same rule. But how do I know the adjoint of A? Now for this, my adjoint becomes, I'll simply swap my elements. Swap my elements. For this, the adjoint becomes, for this, I'll take this over to this point. My leading diagonal, I'll swap it. And for my second diagonal, I'll swap it, but I'll be adding a negative sign. For this, I'll get what? D, A. And for this, I'll be having a what? A, B, C. For your second diagonal, you add what? You multiply them by a negative sign. So I'm having a minus C and minus B. Therefore, for a 2 by 2 matrix, the inverse becomes 1 over the determinant of this. Let's call this A. Alright. And this is the adjoint multiplied by this, whatsoever we have here, D minus C minus B and A. Alright, so this gives us what? The determinant, the inverse of a 2 by 2 matrix. Get what? Your determinant. After that, get what? Your adjoint, which is just this. You don't need to go through the stress of finding cofactor and the transpose, please. So you just get this and you're good to go. Alright, let's take this example. Given a matrix A equal 1 0 1 2 1 3 4 2 1. A, find the inverse of A, right? And B, show that A, the matrix A multiplied by the inverse of A is equal to I, where your I is what? The identity matrix. Alright. Is the identity matrix. Okay, let's solve that. Solution. The matrix A is given as 1 0 1 2, 1, 3, 4, 2, 1. We are asked to calculate to find what the inverse. Recall that the inverse of a matrix is given as 1 over the determinant of the matrix times the adjoint of the matrix. Alright, so this is it. So we work with what we are given. So in finding the inverse of A, we need what? Our determinants. The first step is to calculate what? Your determinant. So let's find our determinant. How do we do that? So the determinant of A, alright, let's do that. A is already given. So in getting your determinants, you create what? A 2 by 2 matrix, right? So create a 2 by 2 matrix. How do you do that? Work with your sign convention. Using what? Just the first row alone. Just the first row, since you're not dealing with a cofactor. We deal with what? The first row alone. And for the first row, I'm having what? A plus, minus, plus, right? So I'll pick my first number there, which is what? 1. And then do what? Create a 2 by 2 matrix. Creating a 2 by 2 matrix, you cover the rows and columns on which that element appears. And my first element there is 1. So I'm covering the row and the column on which it appears. So if I cover this and this, what are the elements left? 1, 3, 2, and 1. So I'm having 1, 3, 2, and 1. Alright, we go over to the next element, which is what? A minus 0. A minus 0, what does that tell you? Minus 0. Okay, let me just write it down. Minus 0. If I multiply anything, it gives me what? 0. Right? So is there need of writing it? No. Right? So if I have a 0 there, multiplying it with whatsoever matrix I have gives me 0. So there's no need, except you just want to write. Okay, next up, let's go over to the next element there, which is what? A plus 1. Plus 1. Plus 1. Cover the row and column on which it appears. So I'm covering this and this. Therefore, I'm having 2, 1, 4, 2. 2, 1, 4, and 2. Okay, therefore your determinant becomes 1 bracket product of what? Leading diagonal. 1 times 1, 1 minus the product of what? Your second diagonal. 2 times 3, 6. Right? Plus 1 product of your principal leading diagonal, 4 minus the second diagonal, which is what? 4. Right? Therefore, I'm having 1 minus 6 gives me what? A minus 5. Plus 1, 4 minus 4 gives us what? 0. Therefore, I'm having 1 times this minus 5. 1 times 0 gives you 0. So minus 5 plus 0 gives us what? 0. Therefore, the determinant of this matrix is what? A minus 5. Alright. So we've gotten our determinants. Next up, we calculate what? The adjoint of A. Adjoint of A. We've gotten this. So we need this now before simplifying. We know that the adjoint of A is simply what? The transpose of the cofactor of A. Alright, so we know that the adjoint is the transpose of the cofactor of A. So what do we need now? We just need what? The cofactor first. Then we get what? Our transpose. So let's get our cofactor. Same method, right? Alright, so for cofactor of A, we create what? A 2 by 2 matrix for each point and get our determinant, right? So for this, always remember, write down your design convention anywhere you want to write it so you don't forget. It's a 3 by 3 matrix, so I'm having a plus, minus, plus, minus, plus, minus, plus, minus, plus. All right, remember that, please. When working with cofactor, remember your sign convention. All right, for this, for the first element, I'll be creating my determinant there, right? So this is a plus. So I'll close this, close this. Now the difference now between your cofactor and your determinant, I don't need to write this number again. I don't need to write this number again for my cofactor. So I'll close this part and this part on which this element appears. So I'm having 1, 3, 2, and 1. I'll write it as my first element. 1, 3, 2, and 1. Over to the next element, which is what? A 0. Let's just write it. A minus what? 0. Minus 0. Write it down. Write it down. Minus 0. Okay, sorry. Don't repeat your element. Minus. So we close the row on which it appears and the column on which it appears. So I'm closing this and this. So I'm having 2, 3, 4, and 1. 2, 3, 4, and 1. Next up, I'm having a plus. Close the row and column. So I'm closing this and this. What is left? 2, 1, 4, and 2. 2, 1, 4, and 2. All right. Yeah, you don't need to write it. It's still a plus, right? Okay. Next up, we go over to our next sign, minus, right? And it's on the second row. So I'll start dealing with my second row alone. So I'll cover for this first element now. I'll cover the second row and what? The column on which the element appears. So this is it. It appears at this point and this point. The elements left are what? 0, 1, 2, and 1. Mind you, the sign convention there is a minus, so you have to state it. Minus 0, 1, 2, and 1. All right. Over to the next element. Your next element is 1. You cover the row and column on which it appears. So this is it. I'm covering this and this. All right. For this element, I'm covering this row. It appears on my second row and what? The second column. So I'm having a 1, 1, 4, and 1. 1, 1, 4, and 1. Mine is a positive element. So I'm having 1, 1, 4, 1. I can either write a plus or I leave it. It's the same thing. And finally, for that row, I'm having what? 3, right? Let's cover our 3. The row and the column on which it appears. And I have what? 1, 0, 4, 2. So I'm having 1, 0, 4, and 2. Alright, so let's do the same thing here. Over to our last row, we apply the same method, the same rule. Pick the first element, check the sign, close the row and column on which it appears. So the first element there is 4, and the sign there is what? A plus. So let's cover our 4. We are covering the row on which it appears and the column. So what are the elements left? 0, 1, 1, and 3. Cover this, and this is left 0, 1, 1, and 3. So I'm having positive, right? 0, 1, 1, and 3. Go over to the next element, which is what? Your 2. But mind you, for the sign convention, I'm having what? A negative sign. So I write what? Minus. Create it. Let's create our 2 by 2 there. I'll cover the row on which this 2 appears. This is the row. And cover the column on which it appears. This is the column. Right? So I'm having a 1, 1, 2, 3. 1, 1, 2, 3. 1, 1, 2, 3. Alright. We're almost done with that. For the last element there, our sign convention is a plus. Cover the row and column. This is the row and this is the column. So what do I have left? 1, 0, 2, 1. 1, 0, 2, 1. Alright. So this is it. We are almost done. We've gotten our cofactor, right? We've gotten the cofactor. This is it. But what we need next is getting what our determinants. After getting our determinants, we simplify it and we are done with the cofactor of A. And the next thing we now need is what? The transpose of A. So let's simplify that. In simplifying this, you do same thing, right? Determinant. Get your determinant at each point. At each point, you get what? Your determinant. For this, I'm having what? 1 times 1, 1, minus the product of what? The second diagonal. 2 times 3 is what? 6. Minus, mind you, your sign there is what? A minus. Get the determinant. 2 times 1, 2. Minus 4 times 3 gives you what? A 12. Alright. And finally, for the last element, I'm having 2 times 2, 4, minus 4 times 1, 4. Alright. Next, we have this minus, right? Minus 0 times 1 gives us what? 0. Minus 2 times 1 gives us what? 2. Next up, 1 times 1 gives us what? 1. Minus 4 times 1 gives us what? A 4. Next up, I'm having a minus sign here. Minus, alright, 1 times 2 gives me what? 2. 4 times 0 gives us what? 0. Minus 0. Finally, the last rule, I'm having what? 0 times 3. 0. Minus 1 times 1, 1. Minus, always remember that. Minus, your sign convention. Don't forget that. 1 times 3 gives me what? 3. Minus 2 times 1 gives us what? 2. Finally, 1 times 1 is what? 1. 2 times 0 is what? 0. Minus 0. Alright, so this gives us what? Our cofactor after simplifying. Therefore, my cofactor becomes what? 1 minus 6 minus 5. Minus 2 minus 12 gives us what? Minus 10, right? Minus 10 times this minus. Okay, 2 minus 12 gives me what? A minus 10. Minus times minus gives us what? A plus 10. 4 minus 4, 0. So the next row, I'm having what? 0 minus 2, which is what? Minus 2. Minus times minus gives us what? A plus 2. 1 minus 4 gives us what? Minus 3. 2 minus 0 gives us what? 2. Minus times 2 gives us what? A minus 2. Alright. Over to the last row, I'm having what? 0 minus 1, which is what? Minus 1. Minus 3 minus 2 is what? 1. Minus times 1 gives us what? Minus 1. And finally, 1 minus 0 gives us what? 1. Alright. Alright, so this gives us what? The cofactor of A. We've gotten our cofactor of A. This is what? The cofactor of A. What do we need next? The transpose of the cofactor of A. And as I said earlier, your transpose is simply interchanging your rows and columns. So the transpose of that, let's write that down. The transpose of cofactor of A equal, let's write it down. I'm having what? My row for what? Column. Interchange it. I'm having -5, 10, 0. For the next one, I'm having what? 2, -3, and -2. And finally, I'm having what? -1, -1, and 1. All right. So this is our final answer for the cofactor, for the transpose of the cofactor of A. And always remember that the transpose of the cofactor of A is the same thing as what? The adjoint of A. All right. So our question was get the inverse of A, right? Get the inverse of A, which is what? 1 over the determinant of A times the adjoint of A, which is what? The transpose of the cofactor of A, adjoint of A. All right. From this, my determinant was gotten to be -5 times the adjoint of A times what? The adjoint of A, which is this. -5, -2, -1, 10, -3, -1, 0, -2, and 1. All right. So this is what we have. Therefore, the inverse of A equal, now this is what? Simply your scalar multiplication. So I'm actually multiplying everything inside my matrix by 1 over -5, right? So I'll multiply this by this by this, every term, every element there by 1 over -5. For the first one there, I'm having a -5 times 1 over -5, right? So minus cancels minus, 5 cancels 5. I'm having 1 left, right? 1. The next element there is what? A 2. So I'm having 2 times 2 times 1 over -5. And this gives me what? 2 times 1, 2 over -5. So I'm having what? I can decide to put it in decimal or I leave it in fractional form, right? So let's leave it in fractional form, whichever way you're correct, please. Whichever way you're correct. So for that, I'm having what? -2 over 5. For the next element there, I'm having a -1, right? -1 times 1 over -5 gives you what? A 1 over 5. Please, -1 times 1 over -5. Minus cancels minus. 1 times this. All right. That is for what? Our first row. Do same thing for second row and third row. You're good to go. You're done with that particular question. So this is it. 1 over -5 times 10 gives me what? -2. 1 over 5 times 10. And that gives me what? A -2. For the next element there, I'm having a -3, right? Therefore, multiplying it with 1 over -5 gives me what? 3 over 5. Finally, for that rule, I'm having what? -1 times 1 over -5, which is the same thing as what? 1 over 5. All right. Over to the last rule. I'm having 0, -2, and 1 as my last rule. So this times 0 gives me what? 0. And -2 times 1 over minus 5 gives me what? 2 over 5. And finally, 1 times 1 over minus 5 gives me what? 1 minus 1 over 5. Alright. So therefore, the inverse of the matrix A is equal to this. You can decide to write this in decimal. You'll see